Could you see my presentation?
Yeah.
Okay. Hello, dear participants of the conference. My name is Ada Bedinska. Let me present our work, Road Accident Prevention System. The data from the Traffic Police Department of the Ministry of Internal Affairs over the past 6 months shows that more than 12,000 road accidents caused 1,000 of deaths and more than 15,000 injuries. And our system will be able to provide a faster and more efficient response to potential dangers, help reduce the number of accidents, and protect the lives and health of road users. This chart confirms the need to use this system. Analyzing the chart that shows the traffic accident statistic for 2021, we can see that most accidents were caused by speeding. This is 24% of all causes of accidents on the road, and violation of maneuvering rules also account for a significant percentage. This is 19%, and violation of the rules for not keeping the distance 7%. And we analyzed papers that provide the emergency prevention system task solution, identified negative and positive aspects. We reviewed various accident prevention systems from different automakers, including Toyota Safety Sense, Volvo City Safety, Mercedes-Benz ProSafe, Honda Sensing, and BMW Active Protection. And each system has its own characteristics, and the choice of a particular system depends on the driver's needs and preferences. But in our opinion, the main disadvantages of this system is that they are built into cars by manufacturers. And we decided to develop a portable system that could be installed in any car. Uh, And based on previous research, we have developed a system decomposition diagram. We decided that the system should consist of the following subsystem. So determining the speed of the vehicle in which the system is installed, determining the safe distance to the vehicle in front, determination of the speed of the cars in front of you, recognition of road signs, driver alerts, and a system for collecting information about a vehicle that violates traffic rules. And first of all, we decided to start development with the subsystem for determining the safe distance to the vehicle in front. For this subsystem, we use a cascade hierarchy classifier. You can see parametric diagram for calculating the distance between cars, and the following algorithm is used to determine the safe distance. It is add cascade classifier file to the project and specify the path to the video footage. Cascade classifier for car recognition is created. Video stream is created from a link to video materials. The following frame is looked from the video stream, blurred and converted to black and white color space. Recognize cars in the black and white frame using a cascade classifier. For each detected car is a coordinate are determined based on which the distance to them from the user's car is calculated, and the results of the calculation are used to visualize the safety distance for the driver. Uh, Now let's take a closer look at the car recognition process as shown in the figure. As I said before, you need to read the next frame from the video stream, and as shown is left part of the figure. The next step is to blur and reduce the shimmer using the blurred function, and then the image is converted to black and white color space, and the end a cascade classifier is used to detect cars. If the car is detected, it will be marked on the frame If isn't, the next frame will be read from the video stream anyway. And to determine the safe distance to vehicle in front, we also need to know the speed of our vehicle. After all this will primarily determine the distance. We have considered three cases. In the first case, the user's car is moving at a speed of 120 kilometers per hour, and the distance between cars should be at least 67 meters. In the second case, the car is traveling at 80 kilometers per hour, and the distance between the cars should be at least 45 meters. And in the third case, the car is traveling at the speed of 40 kilometers per hour, and the distance between them should be at least 23 meters. During the experiment, an example of a situation where the car in front is moving at the safe distance was recorded as shown in a figure, and also an example of a situation with an unsafe distance. And the following steps are taken for the detected cars. First of all, set the serial number for the found car. The distance to the car is determined. As next step, the time of passing through points A and B is calculated, which you set beforehand. Based on the time and distance, the vehicle speed is calculated, and based to the speed and distance calculates whether the distance to the vehicle is safe. Displays the serial number of the vehicle, car number, displays the vehicle speed, and displays the safe or unsafe parameter of the distance to the vehicle in the appropriate color. Displaying a square around the detected vehicle is the corresponding color according to the safety. And although if the distance to the car in front of you is too close, the user will be informed about it by a special signal. And conclusions. The integration of subsystems for speed detection, safe distance road sign recognition, driver alerts, and information collection on rule violators allows the system to adapt to changing road conditions, are respond in a timely manner to ensure maximum safety. The purpose of the system is to help and to support the drivers, but the driving remains in their hands. During testing, the system was found to be quite fast and accurate in use. It's capable of recognizing, analyzing, and informing the driver of at a high speed, which will increase the time for the user to make a decision based on the information collected. And in the future, is planned to expand the system functionality, which will further increase its usefulness. A number of additional tests will also be conducted to correct previously noticed errors and increase the system reliability. On this slide, you can see information about the author of this article. And thank you for attention.
Thank you very much, Ada. Dear colleagues, have you questions? No. Okay. Alex, okay.
Oleg Nikolaevich, I saw that Search want to ask the question to Ada. Search is fun.
Search is fun.
Serge, please, two questions.
Alex, have you questions to Ada?
Yes, I have small question, but search before me. I saw the search. Search. Could you ask this question or not?
Okay. Thank you very much. Please search your questions to Ada. Can you hear me? No.
Not here, not here.
So, search. We don't hear you.
Now see, but not here.
Sergio Rossomano. Okay. Yes. And Sergio, we don't hear you. We don't you hear.
Maybe it's necessary to reboot the system or relaunch the browser.
Sergio Rossomano. Yes.
Reconnect maybe.
Yes.
I have question. I have question to Ada.
Please, Tatiana.
This is a problem and estimation problem and obtained model for dangerous cases for in car, but emergency situation in car on road. Do you have methods or models for decision making on road if we have emergency with car? Only speed. Only speed between car. If we have emergency situation on road.
I can try to help with answer. I am
Ada.
one of the authors.
Okay, please,
This
Andrei.
In our system, we not only calculate speeds and distance between the cars, we recognize road traffic lighters signals and the road signs to
No, I understood. This is on road and rules in speed and signal if rules not performing. Serge, did you have a question?
No, Sergio don't reconnected to our meeting.
Okay, I have small question. Can I?
Yes, Alex, please.
Okay.
You can. Your question.
Ada and company, did you research algorithms approaches road accident prevention system, which was implemented to Tesla vehicle?
Ada, please, your answers.
Okay.
Okay, thank you for the question.
Not question.
Maybe don't understand you this question. Yes.
Yes.
Okay, I
don't
repeat.
consider the Tesla model. We consider more simple systems in other vehicles.
Okay. You can research Tesla algorithm in the future, yes or not?
Yes, I think.
Okay, thank you very much for your answer.
Thanks for your hint. Yeah.
What about this time?
Yeah, Sergio, we can hear.
Oh yeah, hooray! All right. Quick question, Nada. You mentioned that there were some experiments conducted. I understand that you implemented the system actually. Is that correct? You have some prototype system implemented, or what kind of experiments did you run?
Thanks for question. We use video materials for testing our systems, but we don't testing on real this system.
Okay. And the second question is just more like theoretical, philosophical, is about human interaction with your system. So imagine the situation: the driver is in a car and following some route. There is already they receive much information from the signs, from observing the road, and then your system begins to alert them again. So it's you intend to help the driver, but actually it may be distracting them from the actual situation on the road. Have you thought about it? I'm not saying like there is a obvious solution to this, but have you thought about this aspect?
Thanks for question. I think about this, but I believe the system help.
What I mean is, like, it depends on the individual, of course. But if you're driving and you keep hearing these noises, like, here is a sign for you, but I already see this sign. I already know what there is a sign there. I already know what the car is turning my way. So it's not clear to me if it's helping me or distracting me. But it's just an aspect to think about. I'm not saying that it's like wrong or no negative comments here, just another aspect more about how humans perceive and interact with that system than the necessity of the system itself.
I think it is individual, and if you're stressful people, yes, it may be don't help.
So I would suggest in a practical system to have some level like of setting for the user to set up the alerts and information that they want to receive from the system.
I think in the future we think about this problem alerts person about the accident situation.
Okay, thank you.
Thank you, Ada. Dear colleagues, have you any questions to Ada? No questions. Thank you, Ada, for your reports and answers of questions. And the second report.